Lesson is over scientific notation, and scientific notation is used for writing numbers that are really big, like this one that would take up a lot of room if you're writing it in a newspaper or if it had to show up on a calculator or something like that. And so we can condense it down with scientific notation. It's also used in numbers that are really small, that involve a lot of decimal places like this. And again, you can condense it down to write it in a smaller area there. There's a few things we need to know about scientific notation. When you write something in scientific notation, it'll always have this format here where it's a number times 10 to some power. Now, the power here that we're looking at the end, that's just going to be an integer. And so remember, an integer is any number, any whole number, and then its opposite. So a number like 4 is a whole number, and then its opposite would be -4. It does include 0. And so really what it means is that this n here is going to be a non-decimal type number when we have that. The C has a restriction on it as well. This number that you write in the front has to be between 1 and 10. Now, it has to be less than 10, so you're never going to use the number 10. You might use 9.9 or something like that, but you're not going to use the number 10. It could be 1, though. So it could be, as you look here, it could be equal to 1, but not to 10. As we look at this big number then, what we want to do is we want to move the decimal place in such a way that it creates a number between 1 and 10. So right now the decimal place is right here. I want to move it in such a way to make it between 1 and 10. So I'm going to move it right here between the 1 and the 3. Because when I move between 1 and 3, I get 1.37. Notice that that's the only place I can move it to create a number between 1 and 10. If I move it here, it's 13.7. If I move it here, it's 137. And if I move it out front here, it'd be 0.137. None of those numbers are between 1 and 10. But the number 1.37 is. So I know my answer is going to look like 1.37 times 10 to. The power is going to be how far I moved it. So I got to count the number of places that I moved it here. And so let's go through and just kind of count it. I'm going to count out loud, and you can kind of count with me as I go here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places there. And so as I go through there, it goes 14 places. You'll want to make sure to double check, make sure that counting is accurate. The last thing, so first we got a number between 1 and 10. Second, we counted how many places we moved the decimal to get to that number between 1 and 10. And then lastly, we want to make sure that we look to see if this exponent should be positive or negative. 10 to the 14th, that's a really big number. So if I want to create a big number, I want to multiply by a big number. And if you have a positive exponents are going to give you big numbers. Here I have a small number. The process is exactly the same. I look to get a number between 1 and 10, and so I move the decimal between the 5 and the 6. That'd be 5.62. I multiply it by 10, and then I look at how many places I moved it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 spots. But this time, I'm trying to create a small number. I don't want to multiply by a positive exponent here if I want to make a small number. To make a small number, I want to multiply by a negative exponent. Remember that 10 to the negative 10th is just like 1 over 10 to the 10th. So it's like 1 over a billion. And so if you're taking something times a billionth, it's going to be a really small number here. And so that's what I have to do here, is when I want to make a small number, I'm going to use negative exponents. When I want to make a big number, I'm going to use positive exponents. Now look at that with going the other way now. If I have 7.56 times 10 to the negative 6, I know that I'm going to have 7, 5, and 6. So I know I'm going to have 756 here. The thing I got to look at, I got to move the decimal 6 places. Am I going to move it 6 places to the right, or am I going to move it 6 places to the left? Well, since I'm trying to make a small number, since I have a negative exponent, I want to make sure I move that 6 places to the left. And so I'm going to go 1, 2, 3, 4, 5, 6, and put my decimal. Make sure you double check. 1, 2, 3, 4, 5, 6. So I did do that correctly there. This is going to be my number here. So negative exponents make small numbers. Positive exponents make big numbers. Now sometimes we could have a situation like this. This is going to apply some of the properties that we've already had. Notice I'm bringing the 2 into here, and I'm also bringing the 2 into here. When I take a power to a power, I multiply. So I have 7 squared times 10 to the 6th power. Now 7 squared is 49, so I have 49 times 10 to the 6th. Be careful, most of the time it'll tell you that it wants it in scientific notation. This is not in scientific notation because the 49 is bigger than 10. So I want to make it so that it's 4.9. Now when I do that, I want to look at it. Before I was going 6 places to the right and my decimal was here. Now I've moved my decimal farther away, so I have to go a little bit farther. Since I have to go farther, I don't want to go 6 places, I want to go 7 places. So again, just to review, make sure you have a number between 1 and 10. Make sure the exponent is how many places the decimal has moved. And then make sure if you are dealing with a big number, make sure you are having positive exponents. And if you are dealing with a small number, make sure that you have negative exponents. I was at a restaurant the other night and I was eating bacon and I was looking around the restaurant and I was very thankful that they have made it so that people can't smoke in restaurants in Iowa anymore. And so then I was thinking to myself, you know, really a smoking section is kind of weird. Isn't a smoking section in a restaurant kind of like having a peeing section in the pool? Have a good day.